Section 2-6 is on algebraic proof. An algebraic proof uses a two-column format of statements and reasons to solve an equation. Each step in the solution must be justified by a property of equality. Let's take a look at some of the properties of equality. This list right here, I'd like you to copy it into your notebook, so please pause the video and copy these down. Properties of equality you're probably very familiar with. The addition property says if A equals B, then A plus C equals B plus C. In other words, you can add the same thing to both sides of an equation and it remains true. Subtraction property is very similar. You're subtracting C from each side of the equation. Multiplication, you're multiplying both sides of the equation by C. And the division property, you're dividing both sides of the equation by C as long as C is not equal to 0, because you can't divide by 0. The reflexive property says A equals A. In other words, anything is equal to itself. The symmetric property, if A equals B, then B equals A. In other words, you can flip-flop things around the equal sign. Transitive property, if A equals B and B equals C, then A equals C. Substitution, if A equals B, then A can replace B. Wherever you see an A, you can substitute in a B. And then the distributive property, you're probably pretty familiar with. Let's try some examples like you'll see in the homework. So it says state the property that justifies each statement. So for number 1, if x plus 5 equals 16, then x equals 11. That would be the subtraction property, because what you're doing is subtracting 5 from each side of the equation. You could also call it the addition property, because addition is just subtracting the opposite. So you could basically be adding a negative 5 to both sides. Example number 2. If 3x equals negative 24, then x equals negative 8. This is the division property, because you're dividing both sides of the equation by 3. You could also consider it to be the multiplication property, because you could be multiplying both sides of the equation by the reciprocal of 3, which is 3 over 1. And the last example, if the measure of angle A equals 15 and the measure of angle B equals 15, then the measure of angle A equals the measure of angle B. This is the substitution property, because since angle A and angle B are equal to the same thing, we can just substitute one in for the other. Let's take a look at how to actually write a two-column algebraic proof. The problem will say write a two-column proof to show that if 5x plus 1 over 2 minus 8 equals 0, then x equals 3. First thing we want to do is to write our given and our prove. The given is the hypothesis. It's the part that follows if. So our given is 5x plus 1 over 2 minus 8 equals 0. And what we have to prove is our conclusion. We have to prove that x equals 3. To do this, we're just going to do two columns. My first column will be my statements, and my second column will be my reasons. The first statement and reason are always very easy. The first statement is always what you're given. So just copy the given, and your reason is that it's given. Statement number 2. Now in an algebraic proof, you basically just have to solve the equation. So the first thing I would do in solving this equation is add 8 to both sides. So that's going to give me 5x plus 1 over 2 equals 8. And the property that I used for that is the addition property, because I added 8 to both sides. Continuing to solve the equation, I would multiply both sides of the equation by 2 to get rid of the fraction. So multiplying both sides by 2 is going to give me 5x plus 1 equals 16. And because I multiplied both sides of the equation, this is the multiplication property. Next, to solve the equation, I would subtract 1 from each side. So that would give me 5x equals 15. Since I subtracted, that's the subtraction property. And the last thing I would do is divide both sides of the equation by 5, which leaves me with x equals 3. And that would be the division property. You know you're finished with a proof when your last statement is what you were trying to prove. Notice that statement number 5 says x equals 3, and that's what I was trying to prove. So I'm basically done with my proof. So some of the properties of equality can also be applied to segments and angles, and we can use these in geometric proofs. Stop the video for a moment and copy these properties into your notebook. So the reflexive, symmetric, and transitive properties also apply to segments and angles. Notice that when we're referring to the segments, they don't have lines over them, and we're using equal signs. When we're referring to the angles, we have the lowercase m in front of the angle to say basically the measure of angle A is equal to the measure of angle A. And again, we're using equal signs. And so the reflexive, symmetric, and transitive property can be used for the lengths of segments and the measures of angles. Let's try another proof. This one is still basically an algebraic proof, but it throws in a little bit of geometry. It says, prove that if segment AB is congruent to segment AC, then x equals 4. In this case, we're given a diagram as well, and we know that the length of AB is 3x plus 15, and the length of AC is 5x plus 7. So let's go ahead and write our given and our prove. Our given is the hypothesis, the stuff that follows if, so AB is congruent to AC, and what we have to prove is our conclusion, which is what follows the word then. We have to prove that x equals 4. So let's make our two columns. First column is our statements, and our second column is our reasons. And remember, the first statement and reason are always pretty easy. You just copy your given. Segment AB is congruent to segment AC. And my reason for that one is always given. Okay. Step 2. Because what I have to prove is x equals 4, and that has an equal sign in it, I really need to change my congruent sign to an equal sign. And remember, I can do that with the definition of congruent segments. So my second statement is the length of AB is equal to the length of AC. And my reason for that is the definition of congruent segments. Remember that from chapter 1. That definition says that you can go from segments being congruent to their lengths being equal, and back the other way, from their lengths being equal to the two segments being congruent. Okay? My next step is looking at the diagram. I know that the length of AB is 3x plus 15, and the length of AC is 5x plus 7. So I'm just going to substitute those in there. So instead of AB, I'm going to write 3x plus 15, and instead of AC, I'm going to write 5x plus 7. And the property that allowed me to do that is substitution. Now I basically have an algebraic equation to solve. So I'm just going to do as I did in the previous example and solve this. The first thing I think I will do is to subtract 3x from both sides. So that's going to leave me with 15 equals 2x plus 7. So I subtracted 3x from both sides, so that's the subtraction property. Notice my abbreviations for reasons 3 and 4. Don't just use SUB, because I won't know if you mean substitution or subtraction. Statement number 5. I'm going to continue solving this equation, so I'm going to subtract 7 from each side, and that leaves me with 8 equals 2x. And again, that's the subtraction property. Step 6, I'm going to divide both sides by 2, so I get 4 equals x. That's the division property. And I am really close to what I need to prove. Notice I need to prove that x equals 4, but my last step is 4 equals x, and they have to be exactly the same. So I want to flip-flop these around the equal sign, and if you recall, the property that allows me to do that is the symmetric property.